When you look up at the night sky, you see a familiar, comforting sight. A sea of stars that make up our home galaxy, the Milky Way. But just beyond the edge of our celestial neighborhood, a magnificent cosmic city awaits. It's a place so vast and so ancient that its light has been traveling for over 2.5 million years just to reach us. This is the Andromeda Galaxy, our closest and most formidable galactic neighbor. For millennia, this magnificent spectacle was just a faint, fuzzy patch of light, a celestial mystery that tantalized our greatest thinkers. To the naked eye, it's a ghostly smudge, an unassuming object in the constellation Andromeda. But with the power of modern telescopes, that faint smudge transforms into a breathtaking spiral, a cosmic island teeming with over 1 trillion suns. It's a place of colossal structures, mysterious phenomena, and a violent, fiery past. But more than just a beautiful sight, the Andromeda Galaxy is a key to understanding our own place in the cosmos. It's a mirror, showing us what a massive spiral galaxy looks like from the outside. It's also a ticking clock, a cosmic harbinger of an inevitable event that will one day reshape our galactic destiny. This is a story of a cosmic journey, a history of discovery, and a look into a future where two galactic titans are on an unstoppable collision course. Get ready to have your perspective on the universe fundamentally changed. Welcome to Astronomical Library. The history of our relationship with Andromeda is a compelling narrative of evolving knowledge. For centuries, our perception of the cosmos was limited by what we could see. And the story of this galaxy is intertwined with the story of our own scientific progress. Marked by great debates and groundbreaking discoveries, early perceptions, and the great Andromeda Nebula. The first recorded observation of Andromeda dates back to the Persian astronomer Abd el-Rahman el-Sufi in the year 964 AD. In his Book of Fixed Stars, he described it as a little cloud. This simple but accurate description remained the primary view for centuries. Without telescopes, no one could truly grasp its nature. Fast forward to the dawn of the telescopic era. In 1612, the German astronomer Simon Marius was one of the first to observe the faint glow through a telescope, describing it as a flame seen through a horn. This was a significant step, but the object remained a curiosity. In 1764, the French astronomer Charles Messier, a meticulous comet hunter, catalogued Andromeda as M31, marking it as a fuzzy object to avoid confusing it with a comet. Still, even through his telescope, it was a blur. It wasn't until the 1880s that things began to change. Isaac Roberts, a pioneer in astrophotography, captured a groundbreaking image that clearly showed the spiral structure of the Andromeda Nebula, cementing its appearance as a whirlpool of stars. This photograph was a sensation, but it also deepened a profound cosmic debate. Was this spiral a part of our Milky Way, or was it a separate stellar system? The Great Debate of 1920. Settling the Island Universe. Question. The question of Andromeda's nature came to a head in what is now known as the Great Debate. On April 26, 1920, at the National Academy of Sciences in Washington, D.C., two brilliant astronomers squared off. Harlow Shapley argued that Andromeda was a nebula of gas and dust and lay within the Milky Way's boundaries, which he believed was the entire universe. He based his argument on the fact that M31 was too large to be an independent galaxy, and that a supernova observed within it was far too bright to be in another galaxy. On the other side stood Heber Curtis. He proposed the island universe theory, a radical idea that spiral nebulae like Andromeda were, in fact, entire galaxies, vast and separate from our own. Curtis pointed to the dust lanes in Andromeda, which looked remarkably similar to the ones in our own galaxy, suggesting a similar structure. He also argued that Shapley's supernova data was misleading, hinting at different types of stellar explosions. For years, the debate remained a stalemate. The answer came from a surprising and elegant source: variable stars. Edwin Hubble and the cosmic yardstick. The true hero of this story is Edwin Hubble, using the enormous 100-inch Hooker telescope at Mount Wilson Observatory, the most powerful telescope of its time. Hubble began a meticulous search for variable stars. He focused on a specific type called Cepheid variables, which changed brightness over a predictable period. In 1912, Henrietta Swan Leavitt had discovered a direct relationship between a Cepheids period and its absolute brightness. By comparing its absolute brightness, its true light output, with its apparent brightness, how bright it looks from Earth, astronomers could calculate its distance. It was the universe's most reliable cosmic yardstick. In 1925, Hubble spotted a Cepheid variable in Andromeda. He painstakingly measured its period and calculated its distance. The result was a staggering 900,000 light-years a distance, far beyond the most generous estimates for the size of the Milky Way. Later, with more precise data, the distance was revised to 2.5 million light-years. The great debate was over. Andromeda was not a nebula. It was a galaxy, and our universe was suddenly revealed to be an infinitely larger, more complex place than anyone had ever imagined. This discovery didn't just add another object to our maps. It completely rewrote the map itself. Andromeda's sheer scale is almost beyond human comprehension. With a diameter of roughly 220,000 light-years, it is more than double the size of the Milky Way, and it contains an astonishing 1 trillion stars, more than double our own galactic count. But what gives it this colossal structure and makes it such a unique cosmic specimen? The enigmatic double nucleus. At the very heart of Andromeda lies one of its most peculiar and captivating features. The double nucleus. When viewed by the Hubble Space Telescope, its central region appears as two distinct points of light, separated by just a few light-years. For years, astronomers theorized that it could be a binary black hole system, the result of a past galactic merger. This would have been a groundbreaking discovery. However, detailed studies in spectroscopy have revealed a more subtle and elegant solution. The brighter of the 2 points, designated P1, is not the true center of the galaxy. It is actually a very compact, eccentric ring of old, red stars that formed long ago. Because of our viewing angle, we are seeing the light from these stars concentrated into a single, bright point, an optical illusion. The second dimmer point, P2, is the true heart of the galaxy. A much younger cluster of blue stars orbiting the supermassive black hole at the very center. This supermassive black hole, designated P2, is estimated to have a mass of 50 million suns. While this is massive, it is significantly smaller than many others found in the universe. The fact that its core is still so active with star formation provides astronomers with clues about galactic evolution and the complex interplay between black holes and their host galaxies. And there's another bizarre discovery. The galaxy's brightest point in X-ray light is not the black hole, but a binary star system. It consists of a low-mass neutron star pulling matter from a much larger red giant. As the matter spirals into the neutron star, it heats up to millions of degrees, releasing a torrent of X-rays that makes it stand out as the galaxy's most luminous point in that wavelength. Beyond the core, the disk and its secrets. Beyond the bustling core, the Andromeda Galaxy structure unfolds in layers. It is a barred spiral galaxy, meaning it has a central bar of stars from which its spiral arms emerge. From our perspective, this bar is almost edgy on, and therefore difficult to see, but its presence is confirmed by infrared observations. The spiral arms are the most iconic feature, a majestic testament to cosmic recycling. They are not solid structures, but rather density waves, like a traffic jam on a cosmic highway. These waves compress the interstellar gas and dust, triggering the formation of new stars. Astronomers have identified at least 2 prominent spiral arms, though it's believed there may be more, and they are not as tightly wound as the Milky Way's. A halo of ancient stars. Surrounding the main disk is a vast, spherical halo of ancient stars and globular clusters. Andromeda's halo is far larger and more massive than the Milky Way's, a sign of its violent past. Recent surveys have shown that this halo is not a uniform sphere, but is filled with streams and clumps of stars. These streams are the ghostly remnants of smaller dwarf galaxies that Andromeda has consumed over billions of years. This galactic cannibalism has been a crucial process in building Andromeda into the giant we see today. Andromeda isn't just a collection of stars, it's home to some of the most extreme and fascinating objects in the universe. Each of these celestial bodies offers a unique insight into the processes that govern the lives of stars and the evolution of galaxies. Andromeda, a star on the brink of annihilation. One of the most extreme objects is AE Andromeda, a luminous blue variable star. These stars are among the most massive and luminous in the universe, but their extreme power comes at a terrible price. With a mass between 50 and 120 times that of our Sun, AE Andromeda is burning through its fuel at a phenomenal rate, living a life of chaotic and unpredictable flares. Its brilliance comes at a cost. Due to powerful stellar winds, the star is losing an unimaginable amount of mass, approximately 2 quadrillion tons of mass every second. To put that into perspective, that's about 20 times the mass of all the water in Earth's oceans being ejected from a single star every second. This extreme mass loss means it is rapidly approaching the end of its life. Within the next million years, a cosmic blink of an eye, AE Andromeda is destined to explode as a supernova, briefly outshining the entire galaxy. The first exoplanet, beyond the Milky Way. Perhaps the most exciting discovery in Andromeda is the potential for an exoplanet. However, the light curve showed a brief, secondary burst of magnification. The only explanation was that a planet was orbiting Mega M7, slightly magnifying the background star's light as it passed. The data suggests this is a gas giant, a planet roughly 6.3 times the mass of Jupiter. While the discovery has yet to be officially confirmed, it would make Mega ML7 be the first exoplanet ever found outside the Milky Way, proving that planetary systems are not a unique feature of our own galaxy. The Great Star Association, NGC-26, Andromeda's spiral arms, are not just home to individual stars, but to enormous star-forming regions. One of the most prominent is NGC-26, a massive and bright stellar association. This region is not a single cluster, but a loose grouping of more than 300 exceptionally bright, hot, and young stars. These stars are so luminous that they can be resolved by telescopes from Earth, an incredible feat given the immense distance. NGC 206 is a living example of what happens when colossal clouds of gas and dust merge. The resulting compression ignited a firestorm of star formation, creating these brilliant cosmic newborns. Andromeda's majestic form is a product of a violent and transformative past. Its interactions with other galaxies have shaped its structure and composition, and these events are the key to understanding its current form. A history of galactic cannibalism. Astronomers have discovered numerous stellar streams and tidal tails in Andromeda's outer halo. These are not random star clusters, but the ghostly remnants of smaller dwarf galaxies that were torn apart and consumed by Andromeda's immense gravitational pull. It is a cosmic history book, with each stream of stars representing a galaxy that Andromeda has eaten. This process of galactic cannibalism is crucial to the growth of giant galaxies. Andromeda's halo is evidence of its many past meals, a stark reminder that the universe is not a peaceful, static place, but a dynamic arena of destruction and creation. The scars of a collision. M32. One of Andromeda's most famous interactions was with its companion, the dwarf elliptical galaxy M32, approximately 800 million years ago. M32, which was once a much larger spiral galaxy, plunged through the center of Andromeda's disk. This was not a gentle flyby. The tidal forces of Andromeda stripped M32 of most of its stars, gas, and dust, leaving only its dense core behind. The high-speed collision had a profound effect on both galaxies. M32 was transformed into a compact elliptical, a ghostly remnant of its former self. For Andromeda, the event left a visible hole in one of its spiral arms. The shockwave of the collision compressed the gas and dust in the area, triggering a massive short-lived burst of star formation. This collision serves as a powerful example of how galactic interactions shape the evolution of galaxies. The most spectacular event in Andromeda's story is yet to come. It's a date with destiny that has already been set in motion. A galactic collision that will one day redefine our night sky and reshape the cosmos as we know it. The cosmic dance begins. Andromeda is not sitting still. It is hurtling toward the Milky Way at an astounding speed of roughly 300 kilometers per second, or 670,000 miles per hour. At this speed, it would travel from Earth to the Moon in just 45 minutes. But even at this breakneck pace, the vastness of space means the collision will not happen for another 4.5 billion years. The realization that our two home galaxies are on a collision course comes from meticulous observations by the Hubble Space Telescope. For years, scientists could only measure Andromeda's approach toward us. But Hubble's precise measurements of its tangential motion, its sideways movement, showed that it is moving almost directly toward us, making a collision not just possible, but inevitable, the cataclysmic merger. When the two galaxies finally meet, it will not be a chaotic demolition derby. The space between stars is so immense that the chances of any two stars actually colliding are incredibly small. The Milky Way's solar systems and planets are likely to survive intact. However, the galaxies themselves will be fundamentally reshaped. Over millions of years, the gravitational pull will cause the spiral arms to warp and tear. Tidal forces will fling some stars into the deep intergalactic void, while others will be forced into new, elongated orbits. The vast clouds of gas and dust will be compressed, triggering a violent and spectacular burst of new star formation. A cosmic fireworks display of unparalleled scale. This is a slow-motion collision. The two galaxies will pass through each other, then the gravitational forces will pull them back for a second, then a third pass, until they finally merge into a single, massive elliptical galaxy. Astronomers have already given this new galactic hybrid a name, Milkomeda, the fate of the solar system. The timing of this galactic merger is a fascinating coincidence. In about 4.5 billion years, our own sun will be in the final stages of its life. It will have expanded into a red giant, its outer layers consuming the inner planets, including Earth. So, the Milky Way and Andromeda will merge into Milkomeda, long after our planet has become a scorched, lifeless cinder. The fate of humanity, however, is a question that transcends astronomical predictions. Will our descendants have migrated to other star systems, perhaps even building a civilization that can survive the galactic transformation? Or will we have disappeared, leaving no trace of our existence? The collision is a profound reminder of our smallness, but also of the vast and ever-changing stage upon which our history is written. The Andromeda Galaxy is more than just a beautiful object in the night sky. It's a testament to the dynamic and violent nature of the universe. From its long, complicated history of discovery to the mysteries hidden within its core, every new piece of information teaches us something vital about the cosmos. Andromeda reminds us that our own galaxy is not alone. It is a part of a larger cosmic community, a gravitational dance that has been playing out for billions of years and will continue for billions more. By studying our galactic neighbor, we are not just unraveling the secrets of a single object. We are unraveling the story of galaxies themselves. The exploration of Andromeda inspires us to continue asking fundamental questions. Where did we come from? Where are we going? And what is our place in this grand, cosmic drama? It is a source of awe and wonder, a reminder that the universe is a place of endless discovery. If you enjoyed this cosmic journey into the Andromeda Galaxy, please consider hitting the like button to help this video reach more space enthusiasts. Comment below and let us know. What about the Andromeda Galaxy fascinates you the most? And what cosmic mystery should we explore next? Finally, be sure to subscribe to the Astronomical Library channel and ring the notification bell so you don't want to miss our next adventure. Together, we'll continue to unravel the universe's greatest secrets. Thanks for watching, and we'll see you in the next video.